Today we're looking at journal page 51, inverse variation. If y varies inversely as x, then the relationship between the variables is given by the equation y equals a divided by x, where a is a non-zero constant. For positive real-world quantities x and y, the value of y approaches 0 as the value of x increases without bound, and the value of y increases without bound as the value of x approaches 0. All right, if you would, update your notes. All right, now your notes are updated. Let's take a look at the example. Okay. Enter an equation relating the variables and use it to answer the question. Given that y varies inversely as x and y equals 8 when x equals 9, what is the value of y when x equals 36? All right, so step 1. Write an equation relating x and y by finding the constant of variation a. So we know the equation, since it's inversely, is y equals a divided by x. We know that x equals 9 and y equals 8. So our equation is 8 equals a divided by 9. Okay, so now we're going to solve for a. So real simple, we just divide this by 1 and cross multiply. So 1 times a is 1a equals 8 times 9, and we can use our calculator. So on calculates, so 8 times 9 is 72. So a equals 72. We got that. Let me go back and show the step. 1 times a equals 8 times 9. Okay. All right. Now that we know that a is 72, our equation is y equals 72 divided by x. In this case, we're given x is 36, so y equals 72 divided by 36. So again, we can use our Inspire calculator. So 72 divided by 36 is 2. So y equals 2. All right, go ahead and finish up example number 1. All right, let's take a look at example 2. Okay. Enter an equation relating the variables and use it to answer the question. The time t in hours that it takes a pump to empty a tank of water varies inversely, with the pumping rate r gallons per hour. If it takes 7 hours to empty a tank of water when the pumping rate is 60 gallons per hour, how long does it take to empty the tank when the pumping rate is 140 gallons per hour? Okay, so step 1, write an equation relating r and t. So that equation is t equals a divided by r. Okay, step 2, substitute t equals 7 and r equals 60 into t equals a divided by r. Okay, so we've done that. Okay, now step 3, solve for a. So we cross multiply. 1 times a is 1a equals 7 times 60, okay, which is 420. So a equals 420. Okay. All right, now step 4, find the value of t when r equals 140 and a equals 420. Okay, so our equation is t equals, our a value now is 420 divided by r. So now we know that r is 140. So t, and actually we can just, we were given r, so we can just start with putting 140 right there. Okay. So now 420 divided by 140 equals is 3. So t equals 3. So it takes 3 hours to empty the tank when the pumping rate is 140 gallons per hour. All right, go ahead and finish up example 2. All right, let's take a look at example 3. Okay, example 3. Enter an equation relating the variables and use it to answer the question. The frequency F in hertz of a vibrating guitar string varies inversely as its length L in centimeters. If a guitar string 90 centimeters long vibrates with a frequency of 180 hertz, at what frequency will the guitar string vibrate when the guitarist reduces the string's length to 36 centimeters? Okay, step 1, write an equation relating L and F. So F equals A divided by L. Okay, step 2, substitute F equals 180 and L equals 90 into F equals A divided by L, which we've done. Okay, step 3, solve for A. So divide that by 1, cross multiply. 1 times A is 1A equals 180 times 90, which equals, let's go ahead and put that in the calculator. So 180 times 90 is 16,200. Okay. Step 4, find the value of F when L equals 36 and A equals 16,200. Okay, so that means F equals 16,200 divided by 36. So let's go ahead and put that in the calculator. So 16,200 divided by 36 is 450. So the string vibrates with a frequency of 450 hertz when the string's length is 36 centimeters. Okay, go ahead and finish up example 3. All right. And now look at that. That was the last example. So finish that example up and have a wonderful Wildcat day.